Welcome to another time value of money video. We're looking at some advanced time value of money problems. Let's look at number 3. You take out a 15-year, 7.5%, $300,000 mortgage. Beginning with your date 13 payment, you decide to include a $2,500 principal reduction payment with each monthly payment you make. At what date will your last payment occur? Another good problem. Okay, so let's look here at the solution. Step 1, determine the payment amount. You know very well it's the loan divided by the appropriate PVIFA. Here the R is 7.5 divided by 12, or 0.00625. That's 7% divided by 12 gives us 0.00625. And N is 180, 15 years times 12 months per year. The loan amount is $300,000. That PVIFA is 107.8734. 300,000 divided by that 107.8734 is equal to 2781.04. So our monthly payments are 2781.04, and the original plan is to make 180 of those payments beginning at date 1 and ending on date 180. However, at date 13, this individual decides to add more money. So let's just see what our remaining principal balance is at date 12, when the date that they make their last regular payment. So again, it's just present value of annuity equals annuity cash flow times PVIFA. In this case, the relevant present value of the annuity would be the remaining principal balance at day 12, and that's going to be equal to the payment of $2781.04 that we calculated up here, times the PVIFA with the same R, and now N is 168 because we've already made 12 payments. Excuse me. Here we have 2781.04 times this PVIFA, which is 103.8267, and therefore we see our remaining principal balance at day 12 is $288,746.22. So at day 13 we start making our additional payments. One period prior to date 13 is date 12, so if we start making our regular payments with the additional $2,500 at date 13, then when we use application formula 4, as we see here in step 3, that will give us the value one period prior to date 13, which is date 12. So everything will match up perfectly. Again, remember, beginning with our date 13 payment, we want to include the $2,500 extra amount. Okay? So here we have the remaining principal balance at date 12, $288,746.22, is equal to the new annuity cash flow, which is the $2781.04 plus this $2,500 principal reduction payment annuity amount, times the PVIFA, where R is still 0.00625, and N is, well, that's what we're solving for, N. And so therefore we have $288,746.22 is equal to $5281.04 times this PVIFA, 1 minus 1 over 1.00625 to the n power divided by 0.00625. Right here, I'm going to divide both sides by 5281.04 and multiply both sides by 0.00625. And therefore on the right hand side I'm left with just the numerator here, and I'll write it this way: 1 minus 1.00625 to the minus n power. Next step, I'm going to subtract 1 from both sides, so I have minus 1 plus 0.3417251 equals negative 1.00625 to the negative n. Okay? So over here I have negative 0.6582749 equals negative 1.00625 to the negative n. Multiply both sides by minus 1, and I get 0.6582749 equals 1.00625 to the negative n. And now take advantage of, well, since the variable whose value we're solving for appears as an exponent, then I'll I'll use log. So the natural log of the left-hand side equals minus n times the natural log of the base, 1.00625. And therefore n is equal to minus, or negative, the natural log of 0.6582749 divided by the natural log of 1.00625. And when you do the calculation, you get n is equal to 67.1101. So remember, n, the value n we were solving for, was the n here that allowed us to fully extinguish this remaining principal balance. And we see that the n value, 67.1101 periods. But remember, our first payment was on date 13, which means we'd already made 12 payments. So our last payment then would be on, well, 67.1101 plus the 12 is 79.1101. That means that our since this is 79.1101, it means we'll have a regular sized payment, which now is the combination of the regular payment plus the 2,500, or 528104. We'll have that payment at date 79, but we still need a little more. So there will be a payment on date 80, and therefore the last payment is on date 80 and is a partial payment, because we have 12 plus 67.1101 equaling 79.1101, and therefore we're not done at date 79. We got a little bit more to pay, and so at date 80 we'll make a partial payment. And that's the answer to number 3, and thanks for watching.